All right, geometry video 2 for lesson 6.4. Let's start with some just algebraic problems. So it says, so for what values of R and S is W, X, Y, Z a parallelogram? So notice that these are in the sides of our parallelogram. So we must use the fact that opposite sides should be congruent, right? So XW should be congruent to YZ, and XY should be congruent to WZ. So to find R, I'm going to set 4R plus 7 equal to 7R plus 1. I'm going to subtract 4R on both sides to combine my R's. 7 comes down. 7 minus 4 is 3R plus 1. I'll subtract 1 on both sides to move my constants to the left. So 6 is equal to 3R. And I'll divide by 3 to get R alone, and R is 2. So there's your value of R. To find S, again, let's use these two sides. So let's take S plus 5 and set it equal to 2S minus 2. I'll go ahead and subtract this S. It's just a 1S if you need to put the 1 in front. So the 1S is canceled. 5 equals 2 minus 1 is 1S minus 2. Add 2 to both sides to get the constants. This is a 7. And again, you don't need the 1 in front of the S. So that's just what S is. S is 7. Done. Pretty basic solving equations. Okay, next question. For what values of A and B is R, S, T, U a parallelogram? So if we take a look here, I think we're using the idea that the opposite angles need to be congruent because they give us A's and B's and the angles. And notice that it is S and U that have the A's. They're opposite angles. They need to be congruent. And then the R and T have B's. They're opposite angles, so they need to be congruent. Okay? So to find A, let's set 5A equal to 3A plus 14. Let's move the 3A to the left to combine the A terms. 5 minus 3 is 2A equals 14. And divide by 2, and A is 7. For the B angles, let's set 4B plus 1 equal to 3B plus 37. Let's subtract 3B on both sides to combine my B's. 4 minus 3 is 1B. Again, that 1 doesn't have to be there. 1B plus 1 equals 37. Let's subtract 1 on both sides. Again, I'm going to drop the 1 from the B, so B equals 37 minus 1 is 36. And there's your values of A and B. Okay, we have 2 more ways to prove a quadrilateral is a parallelogram. The next one involves the diagonals. So again, these are converses if you remember. So if the diagonals of a quadrilateral bisect each other, then you are a parallelogram, right? So if you know in this picture that AX is congruent to CX, and you know that BX is congruent to DX, then those diagonals bisect each other, and you have a parallelogram. Now, this one is the new one, right? It's different. It's not a converse. This was not one of the ideas we talked about in the last lesson, lesson 6.3. So this one says, if only one pair of opposite sides is both congruent and parallel, then you have a parallelogram. Big deal, right? Both congruent and parallel. So if we know that segment AD is congruent to segment BC, and we know that segment AD is parallel to segment BC, then we have a parallelogram. Okay? All right. So we are going to do a proof to prove the diagonals one. All right? And we're going to do it right here. So in this problem, we are given that segment AX is congruent to CX, and BX is congruent to DX. It's not marked yet. I'll go ahead and mark it. So AX congruent to CX, BX congruent to DX. We want to prove that this is a parallelogram. Again, we're going back to the definition. A parallelogram has opposite sides parallel. So we need to show both pairs of opposite sides are parallel. And again, the way we do that is by using angle pairs from our parallel lines topic. All right, so we have our statements and reasons here. So I always like to start with the given. So my first statement is going to be that segment AX is congruent to CX, and segment BX is congruent to DX, and that is given to me. And it looks like I can prove these two triangles congruent, or the top ones. It's up to you. It's whatever you want to do. I'm going to prove the left and right triangle is congruent. So right now we already have two pairs of sides, a side here and a side here. So I believe that this angle and this angle are congruent because they are vertical angles. I'm going to name it 3 letters. AXB, angle AXB is congruent to angle CXD. And that is because vertical angles are congruent. The vertical angles theorem. And now we're also going to have to prove. So if we prove these two triangles congruent, right? These two, I think we're going to be able to show that A, B, and CD are parallel. But I also think we need to prove the top and bottom triangles congruent so that we can prove that BC and AD are parallel. So we also have to use this pair of vertical angles up here and here. So let's just say it in the same statement, right? And I'll try to go back and forth from blue and red. So let's call this top angle the bottom angle AXD is congruent to angle AXD CXB. And again, that's also because of vertical angles. So I'm just going to put it right in that same statement. Okay, so now this is the angle pair I need. So I believe that these two triangles are congruent by side, angle, side. So I'll use the same naming as I did with the angles. So triangle AXB is going to be congruent to triangle CXD. And that is by side, angle, side congruence. In that exact same statement, I'm going to use the other blue triangles, again, because they have two congruent sides and the angle in between. So we'll say triangle AXD is congruent to triangle CXB. And again, it's also by side, angle, side. So now, typically, in order to prove triangle lines parallel, we need angle pairs. And we're going to use alternate interior angles. You need to pick a pair of alternate interior angles from these congruent triangles. So from the left and right triangle, I'm going to pick the angle here at A and the angle here at C. Okay? So that would be angle BAX is congruent to angle BAX DCX. And that would be not because they're alternate interior angles, but that would be CPCTC from the congruent triangles. In the blue triangles, in the top and bottom, I'm going to pick the angle here at B and the angle here at D. So let's call that top angle, let's call it C, let's do the bottom one. Let's call it ADX. So ADX is congruent to CBX. And that is again because of CPCTC. So I'm going to finish the proof over here, right? So this is my statement number 5. So now that I have those alternate interior angles congruent, right? So for BAX, that's formed by this line and this transversal, right? DCX is formed by that line and that transversal. Those are your alternate interior angles. So because the alternate interior angles are congruent, segment AB is parallel to segment CD. Converse to alternate interior angles. Remember, it's a converse when you prove the lines parallel. Same thing in the blue triangles. To get angle ADX, you need segment AD and this diagonal. To get CBX, you need segment CB and the same diagonal. There's your Z. There's your alternate interior angles. So AD is parallel to CB. Same reason. And because you now have a quadrilateral with both pairs of opposite sides parallel, we know that ABCD is a parallelogram. And that is by the definition of a parallelogram. And that proof is done. So that is why you should believe that if you have the diagonals bisecting in a quadrilateral, it makes the quadrilateral a parallelogram. Okay, I'm going to stop the video there and do a third video. I know it's becoming a habit. I apologize. Quadrilaterals. Once you add that fourth side, man, it requires a lot more talking. All right, so here comes the third video.